Good morning, dear participants. Nagaraj sir, ನೀವು unmute ಮಾಡ್ಕೊಳ್ಳಿ, please. ನಾಗರಾಜ್ ಸರ್ ನಿಮ್ದು ಅನ್ಮ್ಯೂಟ್ ಆಗಿಲ್ಲ ಮೊಬೈಲ್ ಅಲ್ಲಿ. ಹಲೋ
ಈಗ ಸರ್?
ಹಾ ಸರ್, ಪರ್ಫೆಕ್ಟ್. Dr. Siddesh KB, HOD, just also talk with you, sir.
Hello, good morning, Nagaraj sir.
Very good morning, sir.
Very good morning, sir. Thank you for our invitation for accepting the presentation in this FDP.
It's my pleasure,
I
sir.
hope you do well.
Yes, sir.
So please carry on and please feel comfortable. We will meet again after this session, sir. Thank you, sir.
So good morning, dear participants. So here is the day 3 session, morning session with Dr. Nagaraj C. He is assistant professor in Electronics and Communication Department from National Institute of Engineering, NIE, Mysore. He completed his UG in Electronics and Communication from HSC Mysore in the Mysore University. And he completed his PG, MTech in Industrial Electronics from HSC Mysore. It is at the VTU. And in the year 2015, he completed his PhD in the image processing from the Mysore University. And he's worked around 20 years of working experience as a lecturer, senior lecturer, assistant professor, and a professor in various different colleges. He worked in Ponampeta CIT and worked in BGSIT, Mandya, and right now presently is working in NIE, Mysore. So he published more than 19 international journals, 1 national journals, and 10 national conference and 7 international conferences. Totally presented totally 37 number of publications till now, and he contributed towards many things under the VTU, like he worked as a DCS, he become NBA coordinator, he become a project coordinator, he works as a sports committee coordinator, and many more. And his best achievement is he got a best paper award for the validation of EPR embedded medical images using the image variations and the national conference held at RRCE Bangalore. So there's many projects. What are the projects he guided that got with the KSST funding from the government of Karnataka? So thank you, Nagaraj sir, for here. So next of the session will be continued by Nagaraj sir. Thank you.
Okay. Thank you very much, sir. Very warm good morning to everyone present over here for this session. First of all, I'd like to thank SJM Institute of Technology for giving me an opportunity to give a lecturing session in a 5-day training program. Basically stands on signal processing, image processing, and artificial intelligence. So as my friend introduced myself, Dr. Nagaraj C, working as an assistant professor in the Department of EC in NIE, willing to deliver a lecturing session on machine learning for medical imaging. Hope I am audible to everyone.
Yes, sir.
Yeah, thank you, sir, for the confirmation. Nowadays, our health plays a vital role in our daily routine that everyone knows. A person with good health means he is physically and mentally fit. As everyone be knowing, health is wealth. By looking into the person, it is highly difficult to notice his or her health conditions that you. So, in the field of medical, it is possible only through the diagnosis in order to measure the health condition of a particular person. So, one such a kind of diagnosis is medical imaging. That is the one of the topic which I have taken up in this session. And nowadays, you will be knowing that machine learning and deep learning concepts are going to be the wide area where the people are doing so many research and some study kind of activities. So thereby, I have thought of taking that medical imaging concept. If it has been included to that machine learning, it will be a benefit to the end users. Now, for the medical imaging, as you are going to consider, there are different the devices are available in the medical field, like X-ray machines are there, CT machine, MRI, ECG, ultrasound. These are the some important the devices or the machines that are producing the medical imaging that will be useful for the doctors for the purpose of diagnosis. Now, if you look into the meaning of the medical
Recording
imaging,
in progress.
Medical imaging, the medical imaging is a technique. It is a technique or it is a process which will give a visual representation of our body. Okay, and it is mainly useful for the doctor to diagnose the condition of the patient. As I told earlier, there are different machines are there. Okay, so these are the few different the images that can be captured from the machines which have been given already. Through that one that is doctor can easily diagnose the condition of the patient. Now, if you come to the different the medical imaging modality, I have chosen these are the few important the imaging modality. So where the research are carrying okay in the recent trend. The one is X-ray image. The second one is CT image. Third one is MRI. It can be normal MRI or it is a functional MRI or it can be a PET image or it can be an ultrasound image. Now, depending upon the application, so one can select the particular imaging modality for the application. It is up to the researcher area, okay, which one I have to choose for my application. But if you look into that all the imaging modality over here, so here and there they are giving certain informations to the doctors. As an engineer, if we look into that any one of the imaging modality, it is highly impossible to notice what is happening in that particular image. That is the one key thing that we have to agree for that. For a doctor, it will be ease out the task of that particular person. So even nowadays, when you enter into the any one of the hospital, normally what the doctor will suggest, the first he will give the thing is like get an X-ray from that one. Without X-ray or any kind of the imaging modality which I have been shown, they will write a test and they will want that report. Until unless they get a report, they won't give any kind of the diagnosis kind of things to that particular person. So that is the importance of that medical imaging modality. If you get back to the medical imaging modality, so over here I have highlighted a few important the things. So here, what I need to look in mainly over here is, I can go with the X-ray image, I can go with the MRI, CT or ultrasound. Irrespective of that imaging modality, we will be getting certain information out of that one. Now, the four important things we need to look in over here. The one is radiation. The second one is the response out of that imaging modality. Normally, we do call that to be as sensitivity. The third one is the cost. And the fourth one is application or case study. So that means if there is some problem with respect to the brain, I cannot go with the X-ray image like that applications means to be. Then the response, that means the outcome, what we are going to get out of that machine, whether it is suitable for my application or not. That is the second thing. So that means if you go with the X-ray image, you can easily notice that what are the things that we can figure it out from that one. Then the radiation. So whether you go with a X-ray, whether you go with a ultrasound, MRI, CT, the radiation will fall on the body. No doubt in that one, that the amount of radiation will be the one more important thing that we have to consider. Finally, the last one, the cost. So if you go with the normal X-ray, so the cost will be minimum. If you go with the scan like CT or MRI, the cost will be more to that one. This is only to give the input related to the medical imaging. The next one, why do I need to go for the medical imaging concept in the healthcare? So the thing, as you are all been aware, the medical image plays a vital role in healthcare, no doubt in that one. For these kind of the reasons, what have been highlighted. So apart from this, it is not only limited only to the key points which I have been mentioned over here. It will go even beyond that also. The first is early disease detection. So nowadays, we will be noticing that there are different varieties of disease are there. So as a particular for a particular doctor has been considered, detecting that disease at the early stage will be useful for the society. So that medical imaging will play a vital role in detecting that disease at the early stage. How? We will came to know that through the technology which have been there with us. Then the precision of that diagnosis. That means earlier, if you look into that one, so during that condition, before when medical imaging concept was not at all been there, that is that CT scan, MRI, nobody will be easily identify what kind of disease that person is being suffering from. So thereby, it is highly impossible to diagnose such a kind of the patients with that one had been happened. But due to the medical imaging concept, one can predict what kind of disease the particular person is suffering from. Accordingly, the diagnosis can be done with that one. The one more the thing is public health initiatives. It is basically depends upon the population. So that means the population based screening program to detect the disease at the early stage will be the one thing. You might be heard the word called camping. Okay, so from the hospitals and all, they will do eye camp. They will go with the some cancer camp, something like that in newspaper and all. We might have been heard that one. Okay, so that kind of things can be done. So that means through this one, what they will do is they will collect some majority of the input data which is being required for the application. The next one more important thing is training and education. So through this particular medical imaging
Recording
modality,
stopped.
so the physician, that is nothing but the doctor or the researchers will be trained. If it is a physician, through these medical imaging modalities, they can learn and they can improve the diagnosis kind of things which need to be carried out with respect to the specific person. The next one more important the thing is telemedicine. So telemedicine concept is a wide variety of area it is. A particular patient one-to-one. That means in a hospital, a doctor will be allocated to that patient and he will be monitored on a regular basis. Now, how normally we go with the checkup and we will wait for the doctors and we will get the treatment and all, such a kind of things will be done in online mode. So these kind of treatment is not exist in India, but this kind of treatment are being there in some countries like America, Switzerland, etc. That is in foreign countries we can see these kind of telemedicines. And the last one is the research and innovation. So earlier, since there is a lack of data for the researcher, it was been a difficult to carry out their work in the field of medical, making use of the technology. But due to the availability of that digitalization, we can have a repository, that is nothing but data storage can be done, that can be used by the physician or by the technical people to carry out their research and do some innovation kind of things for the applications. So as I told earlier, these are the few important things which will make the medical significance of that medical imaging. As I told earlier, it is not only limited to that one, even beyond that one, we can think and we can work it out for the importance of this medical imaging. The next is machine learning. So machine learning, as you are all been aware, it is a technology where the things can be included to the machine and we can predict the expected accurate outcome out of that particular machine through the learning process. We will go more detail about that machine learning. Now, why do I need that machine learning over here? That is one more important thing that we have to know. The first one is diagnosis. The diagnosis, as you are been aware, health is wealth. A person has to be diagnosed exactly. Even 99.99 is also not acceptable in medical. He has to be diagnosed with 100% accurate. But whatever the machines that you do try, but still there will be some negative points will be there in the machine, but still researchers are working to take it up that diagnosis to reach 100%. So that means earlier it was been not able to diagnose that one by looking into that the medical imaging modality itself. That means one major lacuna, even though we had that medical imaging, is early detection. That is the one major drawback. So because of this technology, it has made the detection and that diagnosis, through that diagnosis, to predict that disease at the early stage. The one more important point is personalized treatment. This machine learning will assist the treatment to the individual patients based on the unique characteristics of medical imaging details. That means some rare diseases will be there. We cannot find or figure out such a kind of disease normally. Under that condition, so this personalized treatment will happen through this machine learning and large scale data analysis. So as I told earlier, the data is the one of the important requirement for machine learning. So due to this medical imaging, we have such a data collection, and using some sophisticated algorithm, that machine learning is capable to work on that large scale data. That is one important thing. Then continuous learning. So there will be always scope to learn. That is machine learning. That is in terms of the model or in terms of its accuracy of the system. As I told, 99.99, even it is not acceptable in medical, there will be always scope to learn the issues using machine learning. The next one is the last one, that is cost efficiency. So since we are using machine learning algorithms, which will automate the system, and thereby it will reduce the cost. Can anyone give the answer how it will reduce the cost? Can anyone? You can unmute and you can give the answer. If there is a machine learning, how it will reduce the cost? Normally, when we visit the hospital, what they will do? They will give so many test conditions, blood test, okay, urine test, okay, some etc., scanning and all. This is what normally we do see in the hospital. So all these can be taken out if I do go with the machine learning. All those unnecessary tests can be avoided. If you have the medical imaging modality with you, they will pass your data. Some unnecessary test can be avoided. Thereby, this tool will be more cost effective with respect to the healthcare has been considered. Now, what are the challenges are there in the medical imaging? As I told to you people, there will be always a challenge like improving the performance of the model that will be there. Apart from that one, in the field of medical, it is a challenge for the physician to predict the rare diseases. We might have been seen that COVID-19 case, how it was arrived and how it disturbed the whole world scenario. Such a kind of rare diseases, if they appears at the time, okay, it will change the whole scenario. So for a medical engineer or in the field of medical for the physician, it is a challenge to detect that kind of rare diseases. That will be always a challenge for both the field, whether it is a technical field or it is been for the medical field. Then one more important thing is detection of the cancer at the earlier stage. The people that is disease, no doubt, that will be in the third stage or in even in the final stage, okay, for that particular patient, which is highly impossible to save the person except some few conditions. But if the technology will help it out to diagnose such a kind of risky cancer diseases at the earlier stage, one could have been saved the life of that person. Apart from these two major challenges, when we want to develop the particular model, so ultimately detection can be done only through the devices. And when we are going to implement the device, these are the three things that will comes into the picture. The first one is adaptable image analysis technologies enabling efficient development. That is the first challenge. That means that modality, what it has to take, that device, it should not be for a unique data what you are going to provide. It should work for all. That is the meaning of that. The second one is the tools and approaches. So there are several tools will be there to make that particular concept into the device, and it should be more effective in deciding that kind of issues. The last one is that algorithms, what you are going to use. It has to be more heterogeneous on that image modality, what we are going to use. These are the few important challenges are there, okay, from both the end. That is in the field of medical and in the field of technology at the time of shaping out that idea into the product. So now let me to go with the task. Suppose if I have been given a program to perform simple
ಮೇಡಮ್ ಇದು
addition.
ಮಾಡ್ಕೊಡ್ತೀನಿ ಫಸ್ಟ್ ಇಯರ್ ಹೊಡ್ರಿ ನಾನು ಹಂಗ ಹೆಲ್ಪ್ ಆಗ್ತಾರ ನಂಗಾರಿ ಪಿಪಿಟಿ
Program to perform the addition between two numbers, then normally what will run our mind? Can anyone? Simple addition program. Okay. So the first one, what you ask is the programming language. Sir, which language you do prefer? There are so many programming languages. Okay, so like C, MATLAB, Python, some open source or some licensed versions. The IDEs are been there with us. Okay, so you can make use of that IDE to write your program. Finally, you will write a code to execute, and thereby you will verify that. That's it. Irrespective of that IDE, what you will choose, irrespective of the programming language, what you will choose, 2 plus 3 must be always 5. That is how you do verify, right? So this is the one thing what normally we do it in our regular day. Now, suppose if I have a task called identify the presence of cancer in a patient, then okay, I will go with the IDE. Fine, MATLAB is there with me, Python is there with me. Okay, fine, I will start writing a code to that. So, how to do the verification and all? Suppose if there is a change in that image modality, so what I need to do? It is not going to be an easy task, just how we have written a program for addition or been any other task. Then ultimately the solution. So that means the solution with us for these kind of issues will be either I have to go with the AI, or either I have to go with the ML, or I have to go with the DL. That is artificial intelligence, machine learning, deep learning. So without that, the people earlier also doing the detection, no doubt in that one. Without these, we can also predict the presence of cancer. As I told to you people, that accuracy is the one of the important the things which falls in the field of medical. If you want to achieve high accuracy and the processing time, at the minimal time you have to achieve this with the normal image processing, it will be little bit tougher job to do that. That's it. I cannot say it is impossible. It is a bit tougher job. So then what is the major difference between our traditional programming and machine learning programming? So in traditional programming, normally we are supposed to provide the input. As I told, 2 and 3 I had to provide. I will write a program for addition using any one of the programming language. I will get my outcome. That's it. Unless you change the input. That means if you record that input to 6 and 7, it will remains the same. That's it. This is the normal traditional program how the people will come up with. Suppose if you go with a machine learning, here it is an automatic process. That machine will automatically predict the things out of the available data. Now for the machine, what I need to feed? I need to give the input, and also I need to give my expected output for that machine. You will write some algorithms to that, thereby you will develop a model out of that one. Once the model is ready, okay, so that based on that performance, that model can be, that means that output is once again taken as an input. That means there will be always a feedback connection in machine learning. So from the outcome, it will take the feedback. If it is not attained the accuracy, the model can be tuned on its own. That is the automatic process, which has not been done in the normal image processing applications. So till you reach your requirement, the model can be trained. That is nothing but it can be tuned through the available algorithms. Now this is a simple chart which will shows AI, ML and deep learning. I'm not going in detail, just I'm giving the flavors of medical imaging modality and machine learning, and followed by few algorithms and one application I have chosen for this particular session. So as you can see, AI, it has been started. It is an AI full form, you'll be knowing that, artificial intelligence. Each and everything are being machine dependent. It will enable all of these things, will enable the machine to think. How we people are thinking in the same way through algorithms, those machines we are training to think in that way. That's it. That is what actually we are doing. If you go with the normal machine learning, it is a subset of AI. If you go with the deep learning, it is once again a subset of machine learning. Based on the availability of the data and based on the availability of the layers, you can differentiate machine or a deep learning. That's it. Now this is the one more important, okay, so the thing. So why machine learning? That is the one thing. Okay, so have given 6 different the points with respect to the choosing that machine learning. So depending upon the application, you can go with either a deep learning or a machine learning area. There is no much more difference in that one. So the thing what we need to know is, okay, so the first point, what it states over there is, some tasks cannot be defined well. They expect by examples. That is what I have given a simple program like addition and detection of the cancer. Now, if I given a cancer detection, or here an example, it is given as recognizing a person or a people. It is not been an easy task if I go with programming in a normal way. How you will start? What need to be done? It has not been so easy, right? So thereby, there is a need or a scope for machine. If I do train, if I look in a mass, if we look our parents, we can easily recognize our parents or our children's in that huge crowd also. In such a way, it also do that one. So that is where, okay, that machine learning requirement will come. The one more important, the point of that one is the human designers often produce machines that do not work as well as desired in the environment which they are used. As I told, the one major important thing for that one is that accuracy. So if the system is not working with that accuracy, it is of no use at all. That is what I do think with respect to the medical issues are being considered. So thereby, so there is a need for machine learning. So apart from that one, the environments change over time, and the amount of knowledge available about certain tasks might be too large for explicit encoding by humans. So that means how many case studies that a particular physician can remember. So it is highly impossible, right? So thereby, so the machine learning will comes into the picture, where you can store n number of the data. That will be in terms of even millions or even more than that, the data can be taken as a part of pre-reference by that particular machine, and it can diagnose. So thereby there is a requirement for machine. Now if you go with the machine learning algorithms, so basically, so there are two different areas. One is either it can be a supervised or it can be an unsupervised learning. In supervised learning, labeling is must. In unsupervised learning, there is no requirement of labeling for the medical data. Suppose if you go with the supervised learning, either you can go with the regression or you can go with the classification. So if you do go with the classification, it can be a binary, it can be a multi-class, or it can be a multi-label classification. How to do the labeling and all, I'll just run a program at the end. I'll show all those things. Now, if you go with the classification, yes or no condition, that's it. Two classes will be there in that. If you take an example of a vehicle, whether it is a car or a bus, that is a one binary classification you can have. So where you can have only two classes for the category, you can call that under binary classification. Multi-class, more than two. If you add the color to that, like red, green, yellow, more than two, that is sufficient, can be come under multi-class. Multi-label class, I have car, if I add color to that, red, yellow, green, blue, it is a multi-class and also have labeled as car and bus. It is multi-labeled classifications. So like that, you can have a classifier with application, okay, in the machine learning algorithms. So one is labeling is must. In another area, there is no labeling is required. So where do you find the accuracy with the maximum extent between the two? Supervised or unsupervised? So normally in supervised learning, we are going to get the more accuracy. The reason, it is already trained according to that label itself. If there is no label, there might be a chance of misclassification. So thereby, most of the people will go with the supervised learning. But you see to it, depending upon the application, I can go with supervised or unsupervised. So one major limitation of the supervised learning is labeling. As I told earlier, if I have to go with the huge data set, then it is a tedious task to label all those data. But supervised learning has got the better between the two. Then ultimately the solution what we do choose is, there is any intermediate is there? Yes, there is a reinforcement algorithm or semi-supervised algorithms are also been there. So for few of the data, we can label it, and the other we can retain as it is, and even that option is also been there with us. Okay, so to train that model, that is semi-supervised learning also been there. And these are the few algorithms under supervised, semi-supervised, and unsupervised learnings. And most of the time you might have been heard SVM classifier, okay, linear regression, and if you go with the unsupervised, you might have been gone with the clustering kind of things in that one. Okay, so these are the algorithms which will be there, and I'll carry out the same with difference between that machine and the deep learning algorithm. If you willing to work out on this machine learning algorithm, what are the algorithms that are being there with us, and you can try with any of the algorithms which have been present over here. We cannot ensure that SVM is always going to be the best for all the application. So for my image modality, sometimes that navy bears or decision tree might give some better performance. So depending upon the image modality, you are allowed to test all the algorithms for your applications, which will suit. You can have that model for the training purpose, and you can fine tune its accuracy accordingly. Now, if you go with the deep learning algorithms, here people mainly concentrate on CNN. Nowadays, even the people are working out on GAN also. So, as a part of the CNN, these are the major the models which will comes inside of that one. You might have been heard AlexNet, ResNet, MobileNet, VGG, Inception V2. So apart from that one, here I have given n number of the CNN models which can be used for a huge data to train the model under deep learning concepts. Okay. So the next the thing is steps to solve the problems under supervised learning. As I told to you people, so supervised learning will give the better accuracy. That's why I have chosen supervised learning. So here I have highlighted the few important things. So the first thing is gather the data. So depending upon the application, what you are looking into, first thing is you should gather the data. You should have the collection of data with you. Once the data is ready, you prepare the data accordingly. Sir, what it means to be? Data is already there. For what I need to prepare? So in machine learning, the data need to be segregated into test, train, and validate. You prepare the data accordingly. That is the meaning of that. After that one, select the model. Before that one, you decide whether the data is sufficient to go with deep learning or it is sufficient to go with machine learning. Accordingly, you choose the model under that category. That's it. Sir, looking into the data, how I can predict which model is best, which I need to train. As I told earlier, so that model is basically depends on the data set, what you have with you and from where you have collected. Thereby, it is highly impossible to decide that model just by looking into that data. You have to test, you have to, before that you have to train, you have to test it. There is no other option. As I told, depending on the data means the data set availability is the major decider of that model itself. You have to train and test. So now once the model is trained, okay, that model is trained, okay, so I can rely on that model that it is giving a better result for my prepared data. So once you come to notice that one, Okay, now I need to evaluate that model. After that one, you can start testing that image what you are having to see the performance of that model. This is the key things that are being involved. The one is data should be there with you. You should have a model. Then you prepare a model to train that. Then evaluate that model. Then start testing that model. Or prediction can be done. Now, as I told earlier, data set. Sir, from where I can get the data sets? There are varieties of repositories are available. I have listed a few important data repository for medical image processing because I am working on that medical image. So these are the important the repository from where I can get the medical imaging modality for the applications. Sorry. Okay. Now data you have collected from any one of the repository. Now the second the part of that supervised learning is I need to segregate the data. As I told to you people, so there is an option for the designer to have the data set on his choice. That is, training and test can be done on his choice. So preferably 70-30 or 80-20 will be the best suitable way to train the model. So if you go with 70-30, even you can split in that as training and validation. That is normally 70-30 we do fixed means 70 will be for train, 10 will be for validate, 20 will be for test. You better to keep that 20% for test always. That will be the one way of training a better model. Now you have the data. Now you have divided the data into train, validate, and test. And you have selected the model. Now, when you have selected the model, basically, so from that medical imaging modality, it will fetch the features out of that. It will fetch the features out of that. Once that features are being selected, based on that features, your model, okay, will try to train that particular information. What are the features that you are going to feed to that model? Based on that algorithm, it will try to train. Now, once the model is going to be trained exactly, you can measure the performance of that model also. That will be the next thing. Okay. So in order to measure the model, there are n number of metrics are there with us, like accuracy, precision, recall, f square or f1 square, normally we do call. Okay, followed by some the curves like AUC curve, ROC curve, and MAP curve. These are the different varieties of parameters. For each and every parameter, there will be some thresholds. Based on that threshold, you can evaluate the performance of the model. Okay, these are all the number game. Okay, so accuracy in terms of number, precision in terms of numbers you are going to get. Based on that, you are going to evaluate the model. As I told earlier, some threshold will be there. If you are wanted to have that model for a specific application, means it has to cross the threshold. If it cross the threshold, you can retain that for your application. Otherwise, you have to go with the new model, or I need to go with a new data set. Those are the two options are there with the design. Okay. So till to this, if you have any sort of queries, you can. So just I have given the flavor of medical imaging and machine learning. Now, if there is any problem is there with us, how to take up? This is what I wanted in this session. That's why I have given a flavor, not in detail. If I want to work it out, what should I have is the thing or intention beside this particular session. If you have any sort of the queries or questionnaire, you can unmute and you can.
If any participants having any questions, please ask in the chat box or unmute yourself and you can. If no, we'll move on to the further. Sir will run the one code.
Okay.
Yes, sir, I think no question
Okay,
here.
fine. It will be just like in our classroom, how we will ask the question to the students, nobody will come. So then it will come in
So we got
the.
a question. So we got a question from in a chat box. How to check the presence of a noise in an unknown image?
The presence of noise, that's what. There will be some statistical parameters need to be included in that one. So normally how you can do is the noise can be added manually, or you have a noisy data. That is the one thing that you need to figure it out. If you have added the manually, then through the statistical parameter, the Gaussian curves are been there, and for what kind of audio data that you have, that is the one key thing that you need to look in. So once you figure out these two things, then ultimately the remaining information you can take it as the noise. So that is the one thing what we can go with respect to this. Okay. Hope I conveyed to you.
Yes, sir. Yes, sir.
Okay, fine.
Any more questions? Sir, you can run the program, sir.
Okay, fine. Thank you, sir.
Okay, sir.
Okay, fine. So here I have taken the two different the concept problem. Both one is on my research area, which has been carried out by my student, and the second one is one KCST project which I worked out on the medical image modality itself. The first problem statement here, early detection of CHD, normally we do call congenital heart disease using pulmonar dermatoglyphics. So you'll be knowing the pump features. So through that one, we have identified some early detection of that CHD diseases, which normally occurs even in birth babies. Okay, so such a kind of work we have taken it up, and he has completed his PhD in the last year. So I'm highlighting how we have taken up that task over here. So when a problem comes, okay, so here the main thing what you need to look in is, I need to work out on CHD using any of the algorithm at the earlier stage, and I need to use the data for that. The one thing is I need to know CHD. So these are the different types of CHDs are listed out. So here we are mainly worked out on ASD, VSD and MI. These are the three diseases which we have taken up for our application. And the palm patterns, as I told earlier, that CHD basically depends on the palm patterns normally which we had. So that palm patterns can be in the form of loop, whirl, or in the form of arc. These are the three ways. There is no other, the structures will be there. We have taken this as our features in order to predict the possibility of CHD. Sorry. Now the one key factor which will decide whether the particular person is suffering from CHD is ATD angle. So for that one, we are supposed to locate the tri-radius, that is axial tri-radius. And for that one, we have to fix this leftmost tri-radius and rightmost tri-radius and axial tri-radius, locate the points and get the angle. Okay, so once the angle is detected, then our job is done. This is the one key important the thing what we worked it out, finding that ATD angle in the palm pattern. Now this is a simple algorithm which we worked it out on that. As I told earlier, here we are mainly concentrated on ASD, VSD and MI. So in the algorithm, I have chosen ASD and MI. That is myocardial ischemic. That is the full form of that. Okay. So basically this ASD depends on ulnar loops. That is which I have shown earlier. That is ulnar loops over here. So another one, that is MI, depends upon that whirl features. So we have collected the data. This was the hectic job which we have taken because CHD patient data collecting of that, the repository which have been shown to you people, it has got the data like cancer, retinopathy, okay, kind of informations are been there in that one. Earlier we thought that even this also been there, but we searched a lot of repository, but we couldn't get even a 10 to 15 CHD patients informations. Then we have approached the hospitals like Columbia Asia and JSS Hospital and Narayana Hrudayalaya. These are the three hospitals from which we have collected the data for our research work to proceed further. And when you are doing with the medical relevant the work, at the end of the day, the one of the key thing what the people expected is validation. Now here we have trained the model is ready. Then the second part is testing. The first part is train, your model is ready, trained model is ready. Then the testing phase. The testing phase over here, the images what we have used for the train, we are not supposed to use that again over here. That most of you will be knowing that concept. So at the time of testing, we have to provide a new image to that trained model, and we have to predict accordingly the disease is being predicted or not. Yes or no condition will be there in that, no doubt, based on that threshold. So for that ASD, we have fixed some angles like in between 40 to 45. For MI, it will be between 51 to 56 degree, that ATD angle, which have been shown in the previous slide. based on that one, okay, if it is yes, he is suffering from ASD. If not, he is healthy. He or she will be healthy. This is the research work which we have carried out, and this is a snapshot of that one to predict the presence of the ulnar loops and the whorls in that one. Now, as I told earlier, okay, fine. We have predicted the ulnar loops and we have found the angle and all. Then who has to validate? The model will validate, no doubt in that one. It will give some numbers at the end, accuracy. Then since it is a medical issue, as I told earlier, 99.99 is also not acceptable. Then if you are taking any kind of medical imaging application, it is better to get the opinion from the physician. This is what we did in our research. It is a must thing to take up. So there must be a ethical committee, so which they will clear what the work that you have been willing to do under the supervision of the physician. Okay, and some additional fellow members also been included in that. If they come to conclude that okay, this data can be given from the hospital to the researcher, then they will clear it. It is a must thing for the researcher. So once you have the ethical clearance, then the outcome what you have got, you have to verify it by the physician. That means double verification you have to do if you go with the medical applications. So one is from the model itself, and the second one is by the physician. Okay, so this is the first work. Okay, so I'll take another 5 minutes. Okay, so detecting the eye disease. So this is the one of the project which has been got selected in KSST recently. Okay, and even we have completed that one. And normally what we observed is in eye disease, there are several eye diseases will be there, but normally the people will go with either diabetic, glaucoma, or cataract kind of things. But if we can uh, figure it out, all the diseases trained by one model, that will be a benefit for the end user. This is the thought what we had, and we have proposed our work, and it was been got selected also. And I'll try to show that result. I don't know whether it is possible to share that also. So I've already run that. Is the screen is visible, sir? Yes.
No, sir. Sir, I'll just run the code and just share the slide via.
No, code is already run, sir. Results, because it takes too much of time. That's why I already run that code. The results are there. Just I want to share that. Let me see.
In the Zoom platform, go on share screen.
Yes, sir. I'll
Change
try.
the screen, sir.
Again, I need to share, sir.
Yes, sir.
Is it okay, sir?
No, sir.
No. Now?
No, sir. So please pin it and share.
I'm unable to figure it out over here, but otherwise I will conclude, sir.
Okay, sir. No problem. No problem.
Okay, fine. And over here, what normally we are going to get is that model and that accuracy curve I wanted to show with that. Okay, and also the confusion matrix with how it will give when we do take up any of the task. I thought of to run that slide. Okay, I'm unable to share that. Okay, so with this, I will conclude the session. Thank you, sir.
Okay, sir. Thank you very much, Nagaraj sir. So we'll share the feedback link right now.
Shall we conclude, sir? Dear participants, on behalf of our Department of Electronics and Communication Engineering and SGM Institute of Technology, I want to express our heartfelt gratitude to Dr. Nagaraj sir for enlightening us during this faculty development program. His session on machine learning for medical imaging has not only expanded our knowledge but also inspired us to explore new frontiers in this field. We are thankful for his expertise and the valuable insights he shared today. I hope all the participants have got nice insights from his session. Thank you very much, sir.
Thank you, sir. Even I would like to thank all the participants and also the all the team members behind this particular wonderful 5-day event, that is organizers and the team for giving me an opportunity to provide that information what I had with me to the others. Thank you very much, sir.
Okay, thank
Thank
you,
you,
sir.
sir.
Thank you very much. Dear participants, the feedback link will be shared on the chat box. And the afternoon session will start by 2:15. By Dr. Siddesh KB, HOD Department of E&CE on Artificial Intelligence. Thank you. Thank you, everyone.
Thank you, sir.